Question 1. We have to solve this trigonometric equation in this domain minus 90 to positive 90. So whenever, let me write the question first. Whenever we have such a situation that one of the terms have a denominator, eliminate that denominator by multiplying the whole equation by the same denominator. So cos theta times 2 cos theta will be 2 cos square theta equal to 7 times cos theta will be 7 cos theta minus 3 over cos theta and cos theta will get cancelled out. We will just left with minus 3. Let's put everything to the left side. 2 cos square theta minus 7 cos theta. Okay, so now let's assume that cos theta is equal to, that's an assumption, okay? So this quadratic equation becomes a pure quadratic equation like this. And now you can use your calculator to find its roots, or you can factor like the one I'm doing here. 2t squared minus 6t minus t plus 3. So it gives me two solutions. 2 minus 1 is 0, and from here t minus 3 equal to 0. So this ends up with t equal to half and t equal to 3. And if you see, we had assumed that t is cos theta. So let's go back to cos theta. Either cos theta is equal to half or cos theta is equal to 3. Cos theta cannot be 3 because cos theta value is always between, rather equal to also, between minus 1 and positive 1. So 3 is well outside this range, so it cannot be an answer. This is inadmissible. So we'll focus on the other one. Here we can write theta is equal to cos inverse half, and it's a positive ratio, so we know that cos is positive in quadrant 1 and quadrant 4, but we will not reach to the quadrant 4 because the domain is from minus 90 to 90. That's what they've given. So we can't go beyond 90. That means we will go this way, positive 90, or this way, negative 90. So let's say, what is cos inverse half? Cos inverse half is 60 degrees. So this is 60 degrees and this is 60 degrees. First answer, we always start from 0 degrees. This is the answer, positive 60 degrees. So theta 1, first answer is 60 degrees, and second answer is minus 60 degrees because it's in opposite direction, clockwise direction. These are the two answers. Question 2a part. They say that this is the original function, it has been transformed to this. We have to fully describe the two single transformations in this one. So f 2x minus 3 is the transformed form. So we can see that the x has been doubled here. That means the transformation will be, number one, that this graph is horizontally stretched. Actually it is compressed, but we write stretched by a factor of half. Reciprocal of whatever is the coefficient of x, we get right the reciprocal of that. Number two, this graph has been translated down by 3 units because this is the function. This was the original function here with x inside. The y value has been reduced by 3, so the whole graph goes down. You can also write that the translation is by 0 in x direction but minus 3 in y direction. This column notation can also be written. Any of the two is okay. Alright, let's go on to the B part of the same. The point 5, 6 lies on the transformed curve. That means after transformation, this is the coordinate. So let's say that original coordinate was x, y. After transformation by this f 2x minus 3, we got 5 and 6. So the first transformation was that it has been stretched by a factor of half in the horizontal direction, which is x direction. It means whatever this x was, it was stretched by a factor of half, and then we got 5. So x times half is 5, 2 multiplied with 5, x is 10. So the x coordinate of the original point was 10. Okay, let's talk about the y1. We know there is a translation of minus 3 in downward direction, right? So whatever was the value, we subtracted 3 from it and we got a new y coordinate, which is 6. So y becomes 6 plus 3, which is 9. So the original point was 10, 9, the combination of the two. Question 3. We have a rational function and the domain is x is greater than 1. We have to find the value of ff5. So ff5 can also be written as f of 5. So let's find the internal number first, f5. Substitute x by 5 here. So 5 plus 3 over 5 minus 1, which is 5 plus 3 is 8 and 5 minus 1 is 4. That comes out to be 2. So this question becomes f2. And now we can substitute 2 in place of x in the same function. So 2 plus 3 over 2 minus 1 equal to 5 over 1. Answer is 5. What about the second part? B part says find an expression for f inverse x. So to write f inverse x, we should first substitute, rather interchange the places of x and y. So fx can be written as y, and this is our function. Okay, let's separate this. So we will interchange the position of x and y for finding inverse. So inverse starts here. X equal to y plus 3 over y minus 1. And now we have to isolate y. First we will have cross multiplication, which will be xy minus x equal to y plus 3. Since we have to isolate y, so we will collect these y's on the left side. So it becomes xy minus y equal to x plus 3. And now we can take y as a suffix of a bracket here. So x minus 1 y equal to x plus 3. It is factored. So y becomes x plus 3 over x minus 1. Exactly same. This is its own inverse. So we can write f inverse x is same as x plus 3 x minus 1. Question 4. We have been given a differentiated form of a function, and they say this curve, this is the point on a curve whose derivative is this. Find the equation of the curve. So dy over dx equal to 8 over 3x plus 2 squared. Now if I write it like this, I can take dx to the other side. So it becomes 8 over 3x plus 2 dx. And to find the equation of the curve, I can integrate both sides. Oh, I forgot to write square here. So now integration of dy will be just y, and here I can take 8 out, and I can write this one as 3x plus 2 to the power minus 2 dx. Okay, so to integrate this one, I will add 1 to this minus 2, so it will become 8 and 3x plus 2 minus 2 plus 1 divided by minus 2 plus 1, and further we have to divide it by the differentiation of 3x plus 2, which is 3. Alright, so we can write this is minus 1, correct? So this becomes minus 1 times 3 minus 3. Let's bring it out with 8, so it becomes minus 8 over 3, and this becomes 3x plus 2 to the power minus 1 plus c. Let's write plus c here as well, and let's complete it here. So this becomes minus 8 over 3, and denominator will also be 3x plus 2 to make it positive, plus c equal to y. And now we have to find the value of c to complete the equation, and for that what can we do? We can substitute this number 2. 5 2/3 is 5 times 3 15, 17 over 3, 2 17 over 3. That's the point. We can't use a mixed fraction, so we have to convert it to improper fraction. So now let's substitute y by 17 over 3 equal to minus 8 over 3 3x plus 2 plus c. And let's, okay, we have to substitute x also by 2. So it becomes 17 over 3 plus 8 over, what is that? This minus became positive when it came to left. 3 times 2 is 6, 6 plus 2 is 8, times 3 is 24, equal to c, okay, and this can also be cancelled, 1 over 3. So it becomes 18 over 3 equal to c, and 18 over 3 is 6. So final equation we get is y equal to minus 8 over 3, the denominator is 3x plus 2 plus 6. In question 5, first, third and fifth terms of arithmetic progression are these. So a equal to 2 cos x, a3 equal to minus 6 square root 3 sin x, and a5 equal to 10 cos x, and this is the domain of for x. Find the exact value of x. So general formula for the term is an equal to a plus n minus 1 d. So an is a3 in this case, so let's write a3 will be a plus n minus 1, which will be 3 minus 1 d. So a3 is negative 6 square root 3 sin x equal to a, which is 2 cos x, plus 2d. This becomes the equation number 1. Let's move on to the other one. A5 will be a plus 5 minus 1d, which is 10 cos x, which is a5, equal to 2 cos x a here plus 4d. This is equation number 2. So now since they are asking for x, not for d, so we'll ignore d. What can we do? We can multiply this equation by 2 so that this 2d again becomes 4d. So let's write this equation after multiplying by 2 under this equation number 2. So we have cos x, yes we have cos x. So minus 6 square root 3 sin x, it will become minus 12 square root 3 sin x equal to 4 cos x, and then it becomes 4d. So now we can subtract this equation from the previous one. This becomes positive, this becomes negative, this becomes negative. So these cancel because of that was the purpose of eliminating d. And now we can write rest of them. Let's write the whole thing here in clear form. So let me write it here. So it becomes 10 cos x, and let's bring this to the left side. It becomes minus 2 cos x, and then this is plus 12 square root 3 sin x, which is already on the left side. But this minus 4 cos x, when it comes to the left side, it becomes plus 4 cos x, right? And now we have so many cos. 10 minus 2 is 8, 8 plus 4 is 12. 12 cos x plus 12 square root 3 sin x equal to 0. Nothing was left on the right side. Let's take this one to the other side. So 12 square root 3 sin x remains here, equal to minus 12 cos x. Again went back to the same, yeah, it's okay. So we can divide both sides by cos x so that this becomes tan x and this cos x gets cancelled out. Also, divide both sides by 12 square root 3 over 12 square root 3 so that this cancels out here. So sin x over cos x becomes tan x. 12 and 12 cancel, negative 1 over square root 3, and now we can complete this. X equal to tan inverse negative 1 over square root 3. Tan is negative here and here. Is it in our domain? Let's check out. It is from half of the pi till pi. Okay. And in radians I got angle as pi over 6, which is not our answer. Our answer starts from here till here. So x will be pi, which is this, minus pi by 6, which is 5 pi by 6. In B part, they are asking us to hence find the exact sum of first 25 terms of the progression. I have written the formula here for AP. This is the sum of first n terms. These were the A1, A3 and A5 given, and we got x equal to 5 pi by 6 in A part. So let's substitute the values one by one, the ones we know. 25 over 2 times 2. A is actually A1, the first term. So let's find A here. 2 cos 5 pi by 6. Okay, so this comes out to be minus square root 3. So we'll substitute that here. Plus n minus 1, which is 25 minus 1. D is a problem. We don't have D, so let's find D here. We know the difference between A3 and A1 will be of two common differences, because A2 is in between, which we don't know. So let's subtract this minus this and we'll divide it by 2. So minus 6 square root 3 sine 5 pi by 6 minus, we already know this one, 2 cos x is minus square root 3. So minus square root 3 over 2. And this will be minus 6 square root 3 sine pi by 6. 5 by 6 is positive half. and plus square root 3 over 2. So what do we get here? Minus 6 and 2 will cancel, it will become minus 3. So minus 3 square root 3 plus square root 3 over 2, which is minus 2 square root 3 over 2, and 2 and 2 cancel. So minus square root 3 is overall D. So let's find the sum now. So we know this is minus square root 3 again. Done. So if it is 12.5, this is minus 2 square root 3, and this is 24, and that's minus 24 square root 3. It becomes 12.5 minus 26 square root 3. And if we multiply 26 and 12.5, which we get 325 square root 3 negative. Question 6. The second term of a geometric progression is 54. So A2 is 54. And the sum to infinity of the progression is 243. The common ratio is greater than half. Okay, so R is greater than half. Find the 10th term, giving your answer in exact form. So we have to find A10. So let's interpret this into a formula. AN equal to A R minus R to the power n minus 1. This is what the formula for nth term of a GP is. So A2 will be A R to the power 2 minus 1, which is AR. And it is given as 54. A2 is 54. So here we can write A is 54 over R. This is our equation number 1. Now second part. S infinity is 243. The formula for S infinity is A 1 minus R. So 243 equal to A. In place of A, now let's write 54 over R. And then it is denominator is 1 minus R. So we can write 1 over 1 minus R. Okay, so let's make the one rational number. 54 over R multiplied by 1 is R. R multiplied by minus R is R square equal to 243. And next we can do cross multiply. So let me continue here. 243 R minus 243 R square equal to 54. Okay, so now let's move everything to the right side so that this becomes positive. So 0 equal to 243 R square minus 243 R plus 54 is the simpler form, and all of them are multiples of 27. You can use directly your calculator to do that. I'm doing it this way because I want to simplify the equation. Otherwise it's very simple if you use your calculator. It becomes how much? 9 R square minus 9 R plus 2. And now we have to find the value of R. It's a quadratic equation. It will give us two solutions, and one of them, only one of them, will be greater than half. That's what I think. And that's how we will get our answer. So you can use your calculator, but I'm factoring it. 9R square 6R minus 3R plus 2. 3R is common here. 3R minus 2 minus 1. 3R minus 2. Minus 2. Okay. So it becomes 3R minus 1. 3R minus 2. This one will give us 3R minus 1 equal to 0, which is R is 1/3. This gives us 3R minus 2 equal to 0, R equal to 2 over 3. and this one is greater than half, so we will accept this, we will reject this one because it is less than half. So now we have to find finally the 10th term. Find the 10th term in exact form. So we use the same formula we started with, an equal to a r to the power n minus 1. So a10 will be a r to the power 10 minus 1. So we don't know a. So let's find a with the help of the relationship we got from first equation here. So it will be a equal to 54 divided by 2/3. So I'll write 2 here and third here. So 2 and 54 cancel. 27. 27 times 3 is 81. So a is 81. Let's go back to our calculations here. So a10 will be 81. R was 2/3 to the power 9. And since they're saying we need to write the exact form, we can use our calculator to find the exact number. And by the time I do this, I request you to subscribe to this channel because I'm one of the first people who is solving this paper for you worldwide, and I will solve more papers if you encourage by subscribing, liking my channel. Thank you. And the answer I got was 512 over 243. Question 7. They have given a diagram where this side is 15 centimeter, the other side is also 15 centimeter. The perpendicular from C on line AB is 9 centimeter and B is the center of this sector. Sector is QBC. Okay. Show that the angle ABC is 1.25 radians, correct to 3 decimal places, rather 3 segment figures. That's what part A asks us. Okay, so let's forget the sector for the time being. Let's look at the triangle. And this triangle is isosceles triangle, isn't it? So let me redraw that here so that will be easy to understand. This is 15 centimeter, this is 15 centimeter. That means this angle and this angle will be equal, and they are asking ABC, which is this angle, right? So let's do what? Let's find this triangle. Let me redraw this, and this. This is 90-degree, correct? So this is 15 centimeter, this side, which is hypotenuse of this right angle triangle, and the height of this triangle is 9. So let's redraw this again. This is 9, this is 15. Is it possible to find this angle? Yes, it is possible. We can use sine theta. Let's call this theta, which is opposite side 9 divided by hypotenuse 15. So theta becomes sine inverse 9 over 15, and that is 0.6435. I'm writing 4 digits to be as accurate as possible. So if this angle is 0.6435, now we can find the corner angles of the isosceles triangle because they are equal. Let's call those two angles as x. So those two angles make up 2x. Now we got 0.6435, and their sum is equal to pi, which is 180 degree in degrees but pi in radians. So 2x equal to pi minus 0.6435, and x is equal to pi minus 0.6435 over 2, and that's hopefully will be 1.25. Let me use my calculator to confirm it. And this is 1.25 radians, 3 segment figures. Part B. Calculate the area of the shaded region they have shown here, which is bound by this and this. Okay. So let's focus on this particular shaded area. If I focus on this sector, B is the center and this is the sector. If I somehow find the area of this particular sector and remove this white part, which is a triangle, we'll get the shaded part, right? And that's what we are going to do now. Okay, so area of the shaded part will be the area of the sector BCQ minus area of the triangle CPB. So let's find the area of the sector BCQ first. Area of the sector is half theta r square, and theta will be the angle at the center of this sector. In first part we showed it was 1.25 radians, and we will use the same. So it will be half times 1.25 radians, and radius is not known to us. Let's try to find side BC, which is the radius. So radius is nothing but the side BC of the triangle. And in this triangle, let me redraw the triangle here so that it becomes easy to understand. This is 90 degree. This is 9 centimeter. The angle is 1.25. So we can find the radius, which is the hypotenuse, by using sine theta. Let me use sine theta here. Sine theta equal to opposite of the angle, which is 9, divided by uh, the hypotenuse. That's what we want to find. Let's call it r because it's the radius of the sector, and they will interchange their places when we do cross multiply. So r equal to 9 over sine theta, and theta is known to us 1.25. We'll use it. So let me use it down there. So r is 9 over sine 1.25, and that comes out to be 9.48 centimeters. So we know the radius now, and we can write it here, 9.48. I've rounded it off to 3 significant figures. Square it. So let me put this in my calculator and find the area. By the time I do this, I would like you to subscribe to this channel and motivate me to make more videos for you in future too. I got 56.2 centimeters squared, 3 significant figures. Alright. Now we have to find the area of the triangle CPB. Yeah. So now triangle CPB. The area of a triangle is half base times height. This is the easier one. There are other formula also, but since we know the height 9 centimeters, we have to find base PB. Let's find PB, which is the adjacent side of the theta. So I can use tan theta this time. Tan theta equal to 9, which is opposite, divided by the adjacent. So 9 is opposite and adjacent is PB. So it will be, let's call it Y this time. So they interchange their places again. So Y equal to 9 divided by tan, and angle is 1.25. This comes out to be approximately 3 centimeters. Okay, so now we have the base as well, so we can find the area of the triangle. Half base times height. Height is 9. So 9 times 3 is 27, divided by 2 is 13.5 centimeter square. And finally, the area of the shaded region will be the area we got earlier, which was 56.2, minus the area we got just now, 13.5, will be to 742.7 centimeter square. Question 8a part, it is given that in the expansion of this particular expression, the coefficient of x square is minus 15. Find the value of a, possible value of a. Alright, so we have two parts, 4 plus 2x, which is simplest form, but 2 minus ax to the power 5 will be a problem because it has power 5. We must focus only on x square. Now, since these two parts are multiplying, we should look for something in the second bracket so that it multiplies with 4, we get an x square, something x square. So 4 multiplied by something is something x square. Now what that something should be? That something should be x square itself with a coefficient, right? So in the expansion of this second one, we'll just look for the x square. Secondly, 2x is another term in the first bracket. So 2x multiplied by something should also give you an x square so that you can combine this x square and this x square. So what should I multiply 2x with? We should multiply with something x. So basically these two terms are needed from the second expansion of second bracket, x and x square. So let's focus on that. So 2 minus ax to the power 5. I'm sure that I want ax to the power 1 so that I get an x. And for that I have to write here 5c1 so that this number and this number match. And I will give remaining 4 exponents to the one which is the other component, which is 2. One thing I forgot here, it is minus ax, so I will write minus here, minus ax to the power 1. Okay, this is taken care of. Now we need an x square. So plus, we need an x square. So minus ax to the power 2 will give us x square. And that's why we have to write 5c2. This 2 matches with this 2. And the remaining 3 go to the other one, which is 2, second term. And that's it. These are the two terms we need from the second one. There are 4 more, but they are useless for us. We will not focus on them. So let's simplify this. 5c1 is 5. Minus ax to the power 1 will be minus ax. And 2 to the power 4 is 16. 16 times 5 is 80. And because of this minus, we'll write minus here, 80ax. That is the expansion of this term. What about this? 5c2 is 10. Minus ax square will be a square, x square, and it will become positive because of being squared. It will be positive. 2 cube is 8. And this comes out to be 80 a square x square. And now to get an x square, this ax has to be multiplied with 2x. That's what we said here in the previous part. So we'll multiply this with 2x, and the x squares should be multiplied with 4. So we'll multiply this with 4. So minus 80 ax times 2x will be minus 160 ax square. And here it will be 80 times 4, 320 a square x square. And their sum, they are the only x squares in the expansion of the two brackets. Minus 160 a x square plus 320 a square x square will be equal to minus 15, as they have given that the coefficient of x square is minus 15 in the question. So minus 15 x square. So since 3 of them have x square, we can ignore x square. Just look at this. Let's rearrange the equation, which is 320 a square minus 160a on the left side, and then this 15 can also be brought to the left side, plus 15 equal to 0. That becomes a quadratic equation, and we can use our calculators to find the values of a. These are possible values of a, right? So what I'll do, I will just factor this. So the true answer I'm getting is 40a minus 5 equal to 0, 8a minus 3 equal to 0. This gives me a equal to 5 over 40, which is 1 over 8. And here it will be a equal to 3 over 8. These are the two possible values. Let's say what is the question. Find the possible values. So yeah, there are two values, 1/8 and 3/8. B part of the same question says it is given instead that in expansion of the same expression coefficient of x square is k. It is also given that only one value of a is there and it leads to k. Find the value of k and a. So you may remember in last part we arrived at this one, 320 a square x square was one coefficient and minus 160 a x square was the second coefficient, and they are saying now that this is equal to k x square, not minus 15 like the previous part. So again we will remove x squares, they have no job here. So let's move k to the left side. 320 a square minus 160 a minus k equal to 0. And now we want only one value of a. So whenever a quadratic expression has only one root, that means the b square minus 4ac, which is the discriminant, is equal to 0. Then it will have one value of a. So let's do it here. B here is minus 160. So minus 160 squared minus 4 times a. A is 320 and c is minus k. It should be equal to 0. So it becomes 25600 positive, and again positive because of this negative and this negative. It will be 1280 k equal to 0. And let's move this to the right side. 1280 k equal to minus 25,600. K equal to minus 25,600 divided by 1280, cancel, to be minus 20. K is minus 20. So they're asking not only a, find the value of, sorry, not only k, find the value of a as well. So let's find the value of a here now by placing the value of k, which is minus 20. So it becomes 320 a square minus 160 a plus 20, because minus and there is a negative 20, negative and negative, it will become positive 20. And now we have to factor this again. So let me do it hurriedly. So because it's a perfect square, we'll get only one answer, we know it. So we get 80a minus 20, 4a minus 1 equal to 0. This will be 80a equal to 20, a equal to 1 over 4. And this also gives us a equal to 1 over 4. Obviously, we have to get the same answer. So the final answer is k is minus 20, a is 1 over 4. Question 9. The volume of V meter cube of a large circular amount of iron ore of radius r centimeter is modeled by this. Radius is greater than 2. And iron ore is added at the rate of 1.5 meter cubes per second. So dV over dt is plus, it's increasing, right? It's added. So 1.5 meter cube per second. Find the rate at which the radius of the mound is increasing when radius is 5.5. So they are asking what is the radius rate of change. Okay. So let's differentiate this main equation v equal to 3 over 2 r minus half cube minus 1 with respect to r. So dv over dr will be, so whenever a constant multiplies with the variable containing part, do not touch the variable. So 3 over 2 is copied. We'll just focus on this power of a function. And in this power of function, if we want to differentiate this 3 comes in front and the content of the bracket remains same, but the exponent goes down by 1. So it is remaining 2 now. Further, we multiply by the differentiation of the contents of the bracket, but the differentiation of this will be 1. Differentiation of r is 1 and differentiation of minus half will be 0. So just multiply by 1. And after that we have minus 1 as well. So minus 1, its differentiation will be separate from the rest of it, which is 0 again. It's a constant, minus 1. Okay, so let's simplify this. It becomes 9 over 2 r minus half square. Over dr here, time is nowhere, so we add divided by dt up and down. By chain rule, it doesn't make any difference. But for our question, it will make a lot of difference because we know dv over dt, which is 1.5. So we can write here 1.5 divided by dr over dt, which we want to find out, equal to 9 over 2 r is given 5.5. 5.5 minus, let's write 0.5. This half I can write as 0.5 square. So 1.5 over dr over dt equal to 5.5 times 0.5 will be just 5 and its square will be 25. So 9 times 25 over 2. And now we'll have to carry out cross multiplication because this dr over dt has to be the numerator. So dr over dt equal to 2 times 1.5 cross multiplied and 925 comes down, which comes out to be 1 over 75 or 0.133. Okay, this is the change in radius, meters per second. Okay, so let's go to the B part of the same question, which is this. Find the volume of the mound at the instant when the radius is increasing. So dr over dt is given this time. So we'll use the same relationship which was here. So dv over dt was already given to us. 1.5 over 0.1 is given to us now. Dr over dt equal to 9 over 2. Let's write it as 4.5 for easiness. And this will give us radius. R is unknown at this time. And let's write 0.5 square here. So by this we'll get radius and from there we can find volume later. So 0.1 and 1.5 divided, so it will be 15. So we can bring this 4.5 down here. So 4.5 divides equal to r minus 0.5 square. So to isolate r, we need to get rid of the square with square root both sides. Okay, that gives us 1.8257 equal to r minus 0.5. Now this 0.5 can come here, it will become 2.3257. I wrote so many digits so that my answer is very accurate. Let's go back to the equation they give and let me copy that equation so that we can use it to find volume. So paste it and we will substitute r and we'll get volume. V equal to 3 over 2. R is known to us now, 2.3257 minus 0.5 5 cube minus 1. And let's put this in our calculator. We'll get our volume, which is equal to 8.13 meter cube. In question 10, we have been given a function here, which is a combination of algebraic and rational part, which will be overall a rational function. And that's why they've given that x is positive. Now they're asking us to find a stationary point, and then stationary point is at x equal to 2. We have to find value of k with the help of that stationary point. So to find stationary point, we should first differentiate the function. So f prime x will be 2x, differentiation of this, and then we'll have minus k over x square, and there is no differentiation of 2, 0. Now you might be wondering how I got this one. Let's focus on this. K over x can be written as kx to the power minus 1, and this minus 1 comes in front, becomes minus k, and then it goes down by 1. Minus 1 is minus 2, which can be written as minus k over x square, and that's why I wrote this. Now they're saying that the stationary point is at x equal to 2. That means 2 times 2, f, which is f prime 2. So we substitute each x by 2. K over 2 square is equal to 0. At stationary points, wherever there is a turning point or a stationary point, the gradient is 0 of the tangent at that point. So that's why we wrote it equal to 0. And that will be 4 minus k over 4 equal to 0, and 4 equals to k over 4, and let's cross multiply. It gives us k equal to 16. So the equation becomes fx equal to x squared plus 16 over x. Okay, next part. Determine the nature of the stationary point. So f prime x was 2x minus k over x square, and now we have the value of k, so let's substitute it by its value, which is 16 over x square. Now to find the nature of the stationary point, we will have the second derivative of the same, which is 2. This derivative of 2x will be just 2 minus, by the same concept we can write minus 16x power minus 2, and if I differentiate this, I get plus 32 over x cube. And now if I substitute x equal to 2, at x equal to 2, f second derivative of 2 is 2 plus 32 over 8, which is 2 cube, right? X cube, that becomes 2 cube, and this will be 8. So that becomes 2 plus 4 equal to 6. And this is positive. We are not interested in the value. It is positive. Whenever the second derivative is positive, the stationary point at x equal to 2 is a minimum. So whenever second derivative is positive, the stationary point at that point is a minimum. Let's move on to the C part. Given that this is the only stationary point of the curve, find the value of range, find the range of f. So this is the only stationary point. That means there is no maximum like this. There is no turning back. It is only like this, and this is happening at 2 comma something, right? And for range, we look at the y value. So let's find the y value using the same main equation of the curve, x square over kx plus 2. So fx is x square plus k over x plus 2. So f2 will be 2 square plus 16 over 2 plus 2. So 4 plus 16 over 2 is 8 plus 2. That becomes 14. That means the y coordinate of this point is 14 and y value is always above 14. This is 14, okay? So it is always above 14. So the range of f, the function, is fx or y, you can write greater than or equal to 14. Question 11. They have given the graph of this function and there is a line, vertical line, x equal to 5 over 2, and the point on this curve is 3 6 over 5, and there's a normal on that point. It meets x-axis here. They're saying find the x coordinate of the point where the normal to the curve meets x-axis. So let's call it point A. They're asking us the x coordinate of A. What is the x coordinate? Alright, so to find this x coordinate we must know the equation of the normal, and that's why we'll have to find equation of normal. So normal is a straight line, and the equation of a straight line is y minus y1 equal to minus 1 over m x minus x1, specifically for a normal. M is the gradient of the tangent, and negative 1 over m makes it negative reciprocal of gradient of tangent, and that's what we will use in equation of normal. So y we don't need to know, x we don't need to know, we'll just write them as they are, y minus something and x minus something. We know x1 and y1, the specific point on the curve where the normal is existing, and that point is this. That means we will write here as 6 over 5 and x1 will be 3. So only challenge here is to find m. And to find m, let's find it here. And m will be the differentiation of the curve, equation of the curve, and at x equal to 3. So to differentiate this, dy over dx equal to, we'll differentiate them separately because there is a plus and minus. We'll use sum and difference rule. That means they will be differentiated separate. Differentiation of half x will be just half. Differentiation of 7 over 10 will be 0, so I'm not writing it. Minus differentiation of this one. Let's change it to some other format first. It will be x minus 2 to the power minus 1/3. Right? It becomes power of a function rule. So in that, minus 1/3 will come in front first. So we will write minus 1/3 first, and then we'll write the bracket again. The exponent of the bracket will go down by 1. So we subtract 1 from it. It becomes minus 4 over 3. And further, we differentiate the contents of the bracket and multiply with the rest of it further, and the differentiation of the x minus 2 is just 1. Alright, we have to substitute 3 now. So it will be half plus 1/3, and this x will be 3. 3 minus 2 is 1, and 1 to the power anything is 1. So we don't have to bother about this. Multiplied by 1, we don't have to bother about this. So we can forget everything else. Half plus 1/3 is the gradient of tangent, which is 5 over 6. Now we can't use 5 over 6 here. We have to use negative reciprocal of it. So it will be minus 6 over 5. Alright, let's find the x coordinate of A now, which will be when x axis is cut by any graph, the y coordinate is 0. So we'll substitute that 0 here, and y will become 0 in the equation of normal. So 0 minus 6 over 5 equal to minus 6 over 5 x minus 3. So we can do cross multiply here. 5 multiplied with minus 6, minus 6 multiplied with 5, it becomes positive 30 over 30 equal to x minus 3. So 1 equal to x minus 3. Minus 3 will come to the left side. It becomes 1 plus 3 equal to x. And we got the x coordinate of point A. The answer of part A is 4, is the coordinate x coordinate of the point A where normal is intersecting the x-axis. Okay, let's go to the B part now. B part says find the area of the shaded region giving your answer in two decimal places. So shaded region we can see here. So what we can do, we can again divide this into two parts. So let me draw a vertical line here. So you can see clearly that this is a triangle and we can find the area of the triangle easily. Only challenge will be this part. So let's find the area of the triangle first. Let me write here area of triangle. We know this is half base times height. So it becomes half base is this. We know this is 3. The x coordinate is 3. Here the x coordinate we just found out 4. So the distance between them is just 1. Height will be the y coordinate of point A. Okay, I took that also as A. My mistake. There was already a point A and I named this as A. Should have written as B. Let's call it B now onwards. So the height of the triangle is 6 over 5. So the area becomes 6 over 10 or 0.6. We will use this later. Let's focus on the curve now, and we want the area under curve only this part where x is 5 over 2 till x is 3. This is the area we have to find. And to find the area of this part, we need to integrate the equation of the curve, and this is the equation of the curve again. So y dx will be half x dx plus 7 over 10 dx minus 1 over x minus 2 to the power 1/3 dx. And we need it from 5 over 2 till 3. I'm not writing them here, I will write them on the last step. So the integration of this becomes half x square over 2 plus 7 over 10, and the integration of this is just x minus, again we'll use the one x minus 2 to the power minus 1/3. So in integration, it goes up by 1. So x minus 2 and minus 1/3 plus 1 divided by minus 1/3 plus 1, and further we divide by the differentiation of the contents of the bracket, which is again 1. So it doesn't make any difference, but we'll divide again. Alright, so this is the integration. We'll write plus c here, and it is from 5 over 2 till 3, and we'll substitute these values now. So let me start from here. This becomes x square over 4, and we are substituting 3 first. So it becomes 3 square over 4 plus 7 times 3 is 21. 21 over 10 minus 3 minus 2 is 1. So whatever is its exponent doesn't matter. It will be 1 only. 1 to the power anything is 1. But this becomes 2 over 3. And that is doesn't matter because it's just 1. So 2 over 3. I will write just 2 here and 3 up. Plus c minus. We substitute 5 over 2 now. So it becomes 5 over 2 square will be 25. Let me write here 1 over 4 is already there. 1 over 4, right? And then we'll get 25 over 4. 5 over 2 square will be 25 over 4 plus 7 over 10 and x is 5 over 2 minus 5 over 2 minus 2 to the power minus 1/3 plus 1 is 2/3 over 2/3 plus c. So c and c gets cancelled out, and let's do our stuff. I'm doing it mentally. You can use the whole thing in calculator very carefully, but please do not take it too lightly to enter these numbers, because one mistake will give you wrong answer. Plus 21 over 10 minus 3 over 2, and rather let's open the bracket, minus 25 over 16, 35 over 20, and because of this minus it will be negative, okay, 35 over 20, and this will be positive. So 3 times this will be, let's leave it like this, we'll just use our calculator. So this starting bracket is not needed. Just put this in a calculator and you'll get your answer. Let me use my calculator. By the time I do that, I request you to please subscribe to this channel and motivate me to make more such videos. I am one of the first people to make videos on this paper 12 of winter 2021. So motivate me by subscribing to this channel and liking this video. Thank you very much. After using my calculator, I got 0.482 and some more digits. And we already had the area of the triangle earlier, which was 0.6. So the area of the shaded region equal to 0.6 earlier, now 0.482. I will write 1.08, okay, 3 significant figures, unit square. Question number 12. We are given a circle on which there is a tangent at 0.54. We have to find the area of the triangle OAB, which is formed by the origin and the points where the tangent crosses x and y axes. So we have to find the area of this triangle. So we know that the area of the triangle is half base times height, correct? So to find the base and height, we should know the coordinates of points A and B. Whatever is x coordinate of A is the base length. Whatever is the y coordinate of B is the height. And once we know them, we can use the formula to find the area of the triangle. So now to find the coordinates of points A and B, we should know the equation of the tangent. And tangent is a line which has an equation like this: y minus y1 equal to mx minus x1. X and y are random points on the circle, so we will not change them, okay? But x1 and y1 are the specific points where the tangent is drawn, and that point is 5, 4. So we can use 5 as x1 and 4 as y1. So now only thing left is the gradient of tangent, and gradient of tangent m is nothing but dy over dx. And to find dy over dx, we'll have to differentiate the equation of the tangent, not tangent, the circle, with respect to x. And let's do that by implicit differentiation. Okay, so if I differentiate this with respect to x, I get first 2x, then 2y dy over dx minus 6 plus 4 dy over dx equal to 0. 27 will not have any differentiation because it's a constant. Let's keep the ones with dy over dx on the left side. So 2y dy over dx stays here. So does 4 dy over dx. But 6 and 2x come to the right side, which is 6 minus 2x. So we'll take dy over dx common from this. So 2y plus 4 dy over dx equal to 6 minus 2x, and that's why dy over dx is 6 minus 2x divided by 2y plus 4. But for m, we need to have specific value for m. And for that, what will we do? We'll substitute the values of the point where this tangent is there. So we will just find dy over dx at x equal to 5 and y equal to 4. And let's write that here because that is them. So 6 minus 2 times x is 5 divided by 2 times y, which is y is 4, 2 times y plus 4. Okay, let's write it cleanly here now. Y minus 4 equal to 6 minus 10 minus 4. 2 times 4 is 8 plus 4, 12, x minus 5. And this can be written as minus 1 over 3. Yeah, they can cancel out. Now, we have to find the coordinates of A and B. Let's start with A. For point A, y equal to 0. Why? Because on x-axis, everywhere, the y coordinate is always 0. So in the equation of the tangent here, we will put y equal to 0. Let me change the color to make it clearer. 0 minus 4 equal to minus 1 over 3 x minus 5. So let's cross multiply. It becomes minus 12 equal to minus x plus 5. And if we finish it here, minus 12 minus 5 equal to minus x minus 17 equal to x negative x and x equal to 17. The x coordinate of A point is 17, and that's why the base is also 17. Alright, now similarly we'll find the y coordinate for B, and we'll substitute x equal to 0 when the equation, the tangent passes through y-axis. So we'll write y minus 4 equal to minus 1 over 3, and now x is 0, minus 5. So let's cross multiply again. So 3y minus 12 equal to this minus and this minus will make it positive 5. So 3y equal to 5 plus 12, and let's complete here. 3y equal to 17 and y equal to 17 over 3, and that makes a complete sense. This is a long line, it is 17. The rise is 17 over 3 and the gradient is 1 over 3. That makes perfect sense. So we have the base as 17 over 17, and the height now is 17 over 3. So we can find the area of the triangle now. So area of triangle OAB will be half, base is 17 for us, height is 17 over 3, and that's why it will be 17 times 289, and 2 times 3 is 6 units square. Let's move on to B part, which is this. Point Q and R also lie on the circle. We could see that such that PQR is an equilateral triangle. Find the exact area of the triangle PQR. Alright, it's an equilateral triangle. It means we have to find the area of this triangle, which is equilateral triangle. And being equilateral triangle is very helpful because we know that each corner of it makes an angle of pi by 3, which is 60 degrees, right? And if we want to find the center, we can find the center very easily from the coefficients of x and y in the equation. Since it is starting with x square and y square, so we know that the half of the coefficient of x is the x coordinate minus 6. What is the half of this? Minus 3, and we change the sign, which is positive 3 is the x coordinate of the center of the circle, and negative half of 4 is negative 2. That will be the center now. And now we can easily find out the radius of this particular triangle. So this is the radius and this is the radius. So what will we do? We'll find the radius first, and then we'll find the area of this one triangle, and we know that there are three such triangles. We'll just multiply the area of this triangle by 3 because there are three such triangles. So let's start by finding the uh, radius. So let's find it here. Okay, so we have a circle. Okay, we have a point 54, the circumference, and we have a center, and the coordinates of the center are 3 minus 2, and since we know both the points now, we can find radius by distance formula, which is this: x2 minus x1 square plus y2 minus y1 square. So 5 minus 3 is 2 square, 4. 4 plus 2, 6 square, 36 equal to square root 40. The radius is square root 40. So will be the second radius, which is going towards this direction, square root 40. And this is our target triangle, for which we have to find the area. We know the two sides. If we know the angle between them, then we will use area of a triangle is half AB sine C. AB are the two sides, and angle C is between those two sides. So we know that in an equilateral triangle, each angle is 60 degrees. Half of that will be 30 degrees. This will be 30. And because this is an isosceles triangle, this will also be 30. So the angle we want will be 120. And then we can use it. We use angles, degrees or radians, doesn't matter because sign is there. So area will be of this triangle will be half square root 40 times square root 40 times sine 120 is the angle between these two sides. This becomes complete 40 divided by 2 is 20. Sine 120 will be in the second quadrant right here, 120. So it is 60 degrees. So sine 60 square root 3 over 2. You can use a calculator to find this value. This and this cancel again. So the area of one triangle is 10 square root 3, and we have to find the area of three triangles which are exactly same. So area of triangle PQR equal to 3 times 10 square root 3, which is 30 square root 3. This is the final answer, and we can write units square.